Welcome everybody to the part 4 of this video series on limits. In this video we will be discussing a few formulae from trigonometry and with that let's begin. The first formula is limit of theta tends to 0, sine theta by theta should be equal to 1. Now why this happens is because, see, when you say theta tends to 0, theta is going to be a very small angle, and every time the angle is a very small angle, you can say that sine theta and theta are approximately equal. So for very small angles, if sine theta and theta are approximately equal, you can say that sine theta upon theta, because they are approximately equal, they get cancelled and the final answer will be equal to 1. So limit of theta tending to 0, sine theta by theta will be 1. Mark a very important thing here, that is the term here and here have to be the same. So say for example, I talk about sine 5x upon x when the limit of x tends to 0. You have to take care to see that the term here and here is the same. So because this is 5x, we can make this equal to 5x by multiplying and dividing with 5. Okay, and then x tends to 0 is what we have. We need this term to tend to 0. Now see, if x is approximately equal to 0, multiply both the sides by 5 and you can say that 5x will also be approximately equal to 0 only. So if x tends to 0, then 5x also by default tends to 0. You need not separately write it as 5x tends to 0. But yeah, you need to understand that whatever term has come here is the one which should have come here. We don't separately write it, but it is to be understood that because x tends to 0, 5x will also tend to 0. And after that result is in the format that we require, we can say that the value of this expression will be equal to 1. And finally we had multiplied with 5, right? So finally the value of that question that we had written will be equal to 5. Okay, that is the way you will be using that first result. And in a similar way you have the second result. The second result is exactly the same. Limit of theta tends to 0, tan theta by theta will be equal to 1. Again the same thing, the term here and here has to be the same. If they are different, then you have to make them the same and then you can apply this result. And keep in mind, whatever term you have here, that term is the one which should tend to 0. Okay, if you have, say for example, theta plus 7 out here, then theta tends to 0 is not the thing you should have here. You should have theta plus 7 tends to 0. In short, whatever term you have here or here is the very term that should tend to 0. In these circumstances, the result is very clear in front of you, that is limit of theta tending to 0, tan theta by theta should be equal to 1. Now the third result which I am telling you, it's not really a result in many of the textbooks, but I often use it as a result because as a shortcut it helps you a lot. Limit of theta tends to 0, 1 minus cos theta divided by theta square. Okay, the value for this will be equal to half. I will show you the derivation right away. 1 minus cos theta upon theta square. 1 minus cos theta is 2 sine square theta by 2. If you are not very clear with the formula in trigonometry, then I have left a link in the description box below, and that link is to a video series which is purely dedicated to only and only the trigonometric formulae. Do check out that entire video series once. It's only about 40 minutes. You will get thorough with the formula in trigonometry if at all you don't know them. So once you are clear with that, you will be able to understand in a better way all these formulae. 1 minus cos theta is 2 sine square theta by 2, and we had a limit of theta tending to 0. I was actually deriving the value for this. Okay, so I have written this 1 minus cos theta is 2 sine square theta by 2. Take that 2 in the denominator. In fact, let's keep that 2 outside only. Okay, so we have 2 times limit theta tending to 0, sine square theta by 2 upon theta square. We can write it as sine theta by 2 by theta the whole square. We can take that limit inside the bracket. So when we do that, we will have the expression looking something like this. Now we have limit of theta tends to 0, sine theta by theta was equal to 1. But now here we have theta by 2. So we need to make this theta by 2. And to balance that 2, we will multiply with a 2 in the denominator only. That 2, when taken out of the bracket, will come out as 1 by 4. And finally the value of this bracket will be equal to 1, because this is of the type limit of theta tends to 0, sine theta by theta. So this bracket is evaluating, or it has the value as 1. So we have 2 into 1 square into 1 by 4, which is equal to 1 by 2. And that is how we get the value of 1 minus cos theta by theta square as 1 by 2. Now in your college exams, it is important to go ahead with the entire derivation because this is not treated as a result. Yet if you are solving a sum for any of the competitive exams, this is one result that can be very helpful to you as a shortcut. Now how to use it? Say for example, I give you limit of theta tends to 0. I say 1 minus cos 2 theta divided by theta square. Now what will you do? You need to understand that theta tends to 0, that's fine. It is theta upon theta square. Whatever you have inside the cos, the square of it appears in the denominator. I have 2 theta here. So in the denominator, I should have had the square of 2 theta, that is 4 theta square. So I will write 4 theta square, but to balance that 4, I have to write into 4 over here. The value of this entire expression now as per the formula is going to be equal to half. So I have the answer as half into 4, which is equal to 2. That's how you will be using the third result. But keep in mind, if at all you are using the third result, it should not be used in any of the written exams where you have to write all the solutions with proper steps. With proper steps, you have to go ahead like I had derived that formula. We will check how to do that when I take the sums. But like I've said, as a shortcut, keep in mind this very formula. Let's begin with the questions now. We have limit of theta tends to 0, sin m theta divided by tan m theta. To solve it, we know very well that under sin we need theta and below tan also we need a theta. So we will divide the numerator and denominator with theta. So limit of theta tends to 0. We have sin m theta divided by tan m theta. Divide the numerator with theta, divide the denominator with theta. Separate the limit also. You can definitely evaluate it very easily, but now you have m theta here. The only term you don't have here is an m term. So you bring an m by just writing an m here, balance it by multiplying it with m here. You bring an, okay, there was n theta here, right? Yeah, so n theta. You bring an n term here and you balance it by multiplying it with n in the denominator here. Keep this in one bracket and this in the other bracket and compare it with the result. Limit of theta tends to 0, sin theta by theta, and that should be equal to 1. So we have 1 into m divided by, similarly this is the result for tan. So we have divided by 1 into n, and that gives you the value of the very first question as m upon n. Go ahead with the second question. Well, you might tell me that, so it's the very formula that we had learned, right? But like I said, don't use the formula. Initially, I'll tell you how to use that formula and then we will go ahead with the actual writing pattern of it. So we have limit of theta tends to 0, 1 minus cos 2 theta. I have 2 theta here, so in the denominator I need the square of 2 theta, which is 4 theta square. But I had only theta square. That additional 4 which I have written here, I will balance it by multiplying it with 4 right here. So this will be equal to, the value for this being equal to half, into we have a 4, and this will be equal to 2. Now going ahead with the longer way, we have 1 minus cos 2 theta as 2 sin square theta divided by theta square. Pull out a 2 common and you have sin square theta by theta square, which can be written as sin theta by theta the whole square. Take that limit inside the bracket. So you have 2 times limit of theta tends to 0 sin theta by theta the whole square. This will be equal to 2 into 1 square, which is equal to 2. And that's the value of your second question. Moving on with the third one. Again, you have 1 minus cos x, right? So what you can do is you can just divide the numerator and denominator with x square. When you do that, this becomes limit of x tends to 0. X tan x divided by, we had 1 minus cos x, and I just said you can divide the numerator and denominator with x square. So in the numerator you will have tan x upon x, which is equal to 1. In the denominator you have 1 minus cos x upon x square and limit of x tends to 0. So in the denominator it is half, and 1 upon half, the value for this entire expression will be 2. How to write it in the longer way? It goes like this. Longer way means the way you have to write it in your exams, the college exams, would be this. This is the working that you will keep in mind for the competitive exams. So it is x tan x divided by 1 minus cos x will be 2 sin square x by 2. Okay. You can then divide the numerator and denominator with x square. So you have x tan x upon x square divided by 2 sine square x by 2 upon x square. Split the limit. So one limit goes in the numerator, one limit comes in the denominator. X gets cancelled. We have limit of x tends to 0, tan x by x in the numerator, which will be equal to 1 in the numerator. In the denominator, take this 2 outside. Sine square x by 2 upon x square. So that can be written as sine x by 2 upon x the whole square. Take this limit inside the bracket. So you have limit x tends to 0, sine x by 2 upon x the whole square. Take a by 2 here and balance that 2 by multiplying with a 2 here. This 2 can come outside the bracket. This 2 can come outside the bracket. And you can write it as 4 in the denominator here. So this 2 by 4 makes it half. And the value for this entire expression will be 1 square. Because this is sine theta by theta. Okay, so we have in the denominator half into 1 square, and this should be equal to 2. So the value for this expression turns out to be equal to 2, and that's how you're solving the third question. Moving on with the fourth one, we have limit of x tends to 0. Sec x is 1 upon cos x, and 1 upon cos x minus 1 can be written as 1 minus cos x divided by cos x, and then we have into x square also. So we can now write it as limit of x tends to 0. Okay, I am sure you have understood that 1 minus cos x upon x square will be half. You put x equal to 0 right here. So that will be equal to cos 0, which is equal to 1. So this will be equal to 1 upon 1 into half, and that will be equal to half. But to go ahead by the actual way, what we can do is we can write the numerator as 2 sine square x by 2. In the denominator it is cos x into x square, and we can take that 2 outside the limit. Sine x by 2 and upon x, we can write that in one bracket, the whole square, into we have 1 upon cos x. Split the limit and take this one limit inside the bracket here. So you have 2 times limit of x tends to 0, sine of x by 2 upon x the whole square, into limit of x tends to 0, 1 upon cos x. We will bring a divided by 2 here and balance it with a 2 here. This 2 comes out, becomes a 4 right here. 2 by 4 becomes half, and finally the value is half multiplied by the value of this bracket is 1, and we have the square of it. So into 1 square into 1 upon cos 0, and cos 0 will be 1. So we have into 1 upon 1. So the final value for this expression becomes equal to half. Let's continue with the next question. So this will be limit of x tends to 0. In the numerator you can write, okay, you can just divide the numerator and denominator with x square. So we have 1 minus cos of nx upon x square divided by 1 minus cos of mx divided by x square. Split the two limits. In this sum, I am just following the shortcut method, and you know very well that if you want to go ahead with the longer method, you can write this as 2 sine square nx by 2. Okay, since we have practiced it in a couple of sums earlier, we will now go ahead with the shortcut method so that we can evaluate our answers as quick as possible. We can write n square here and balance it with an n square here, because we had nx, we are trying to bring the square of it in the denominator. Similarly, we have mx here. So in the denominator, we will try to bring the square of this, that is m square x square. We write m square and balance it with multiplying with m square right here. If I keep this term in one bracket and this term in the other bracket, it is very clear that the value of the first bracket in the numerator, this bracket, the value of it is equal to half into n square divided by, even this value is half, 1 minus cos theta by theta square, where limit of theta tends to 0. So that is half into m square. And this becomes equal to n square upon m square. Take the next one. This is limit of x tends to pi upon 6, 2 minus cosec x. Now here you can write cot square x as cosec square x minus 1. So this becomes cosec square x minus 1 minus 3, but minus 1 minus 3 makes it minus 4, and cosec square x minus 4, it's like a square minus b square. So you can write it as cosec x plus 2 into cosec x minus 2. Now you can just cancel off cosec x minus 2 in the numerator and denominator, That will leave you with a minus 1 in the numerator. And finally, when you put the value of x as pi by 6, you have minus 1 upon cosec pi by 6 is cosec 30, the value for which is equal to 2 plus 2, and this will be equal to minus 1 upon 4. Moving on with the third question. Even in the third question, you can perform a similar simplification. In the numerator, it is cos x minus sin x, and the denominator's cos 2x can be written as cos square x minus sin square x, which again is of the form a square minus b square. So the denominator is cos x minus sin x into cos x plus sin x. You can cancel cos x minus sin x in the numerator, and when you put x as pi by 4 in the leftover bracket, we have the value for our expression as 1 upon cos pi by 4, that is 1 by root 2, plus sin pi by 4, which is 1 by root 2. 1 by root 2 plus 1 by root 2 is 2 by root 2. 2 by root 2 will be equal to root 2, and that is the final value of that third question, that is 1 by root 2. Moving on with the next question. Again, you can use very easily the shortcut that we have discussed. So limit of x tends to 0. Write the numerator as 1 minus cos bx minus 1 plus cos ax. Now from the last two terms, pull out a minus sign common. We have minus of 1 minus cos ax, and in the denominator we have, the denominator also we will write it as minus of 1 minus cos cx. You can now divide the numerator and denominator with x square. So there's an x square term here and there's an x square term here. Split the two terms here. So this will be upon x square here and upon x square here. You can split the limit also. So there's one limit in the numerator, there's one limit in the denominator. One limit goes with the first term and the other limit goes with the second term. Now that separation step is not what I am writing. I'll just focus on the further simplification. There's a bx term here and there's an x square term here. So in the denominator we need b square x square. I am bringing a b square here and I balance it with writing a b square right here. And in the middle there is a minus sign. Now here we have ax. We need a square x square here. So I am bringing an a square term here and multiplying it with a square so that I balance off whatever I have introduced. Similarly here I will write c square and I will multiply it with c square here. The value of this entire term will now be half. Even this entire term will be equal to half and this entire term will be equal to half. So the value of this expression becomes half into b square minus half into a square divided by, there was a minus sign here, keep in mind, minus half into c square. You can pull out half common from the numerator and cancel it off with the half in the denominator. That minus also can be put in the numerator, and minus of b square minus a square will be a square minus b square. So the final value for that expression is a square minus b square upon c square. That's how we are solving the third question. Moving on with the fourth, that's how we are solving the first part of the third question. Moving on with the second one. There's a root here, so you can simply rationalize this by multiplying it with root over 1 minus cos x plus root 2 divided by root over 1 minus cos x plus root 2. So when that happens, the value becomes limit of x tends to pi. The numerator is a square minus b square, that is 1 minus cos x minus root 2 square, which is 2 only. So 1 minus 2 will become equal to minus 1. We have minus of cos x minus 1. Take a minus common and you can write it as cos x plus 1. And in the denominator, this sin square x can be written as 1 minus cos square x. 1 minus cos square x is again of the type a square minus b square, and we can write it as 1 minus cos x into 1 plus cos x. And in the denominator, we are finally left with just one more bracket, which is root over 1 minus cos x plus root 2. You can cancel off 1 plus cos x in the numerator and denominator, and the moment you put x as pi right here, keep in mind cos pi will be equal to minus 1. So we have minus 1 upon 1 minus minus 1 makes it 1 plus 1, and here as well you can put that value as pi. So 1 minus cos pi will be 1 minus minus 1, that is 1 plus 1, which is equal to 2. So we have root 2 plus root 2, which is equal to 2 root 2 in the second bracket. 2 into 2 root 2 makes it 4 root 2 in the denominator, and the final value for this expression becomes equal to minus 1 upon 4 root 2. Moving on with the third question. We have limit of x tends to pi by 4. In the numerator, you have a tan square x, which can be easily written as sec square x minus 1. Now we are doing it because we have sec x and cosec x in the denominator, okay? And the cot square x term can be written as cosec square x minus 1. So when you open up the bracket in the numerator, this becomes minus cosec square x and plus 1. Minus 1 plus 1 becomes equal to 0. So we are left with sec square x minus cosec square x. And sec square x minus cosec square x is of the type a square minus b square. So you can write that as sec x minus cosec x into sec x plus cosec x divided by we have sec x minus cosec x. Sec x minus cosec x gets cancelled, and finally you need to put x as pi by 4 in the leftover expression. So we have sec pi by 4 plus cosec pi by 4, both of which are equal to root 2. So we have root 2 plus root 2, which is equal to 2 root 2, and that's the value for the third question. Let's take one last question in this video. So we have limit of x tends to pi by 6. It's a very simple question because all you need to do is factorize the numerator and the denominator. I know that the quadratic is not in terms of x, it is in terms of sin x, but that's absolutely fine. You can factorize it exactly in the way you've been factorizing your normal quadratic equations. So in the numerator, if you try to factorize, the middle term would be, this is 2 sin square x plus, the middle term would be 2 sin x minus 1. In the denominator, it will be 2 sin square x minus 2 sin x minus sin x plus 1. So in the numerator, if you pull out a 2 sin x common from the first bracket, then you will be left with sin x plus 1, and from the second bracket you can pull out a minus 1. So the numerator will be 2 sin x minus 1 into sin x plus 1, and similarly the denominator will be 2 sin x minus 1 into sin x minus 1. So 2 sin x minus 1 gets cancelled in the numerator and denominator, and when you put the value of x as pi by 6, you get sin pi by 6, that is equal to half, plus 1 in the numerator, sin pi by 6, that is half, minus 1 in the denominator. This becomes 3 by 2 upon minus 1 by 2. That minus 1 by 2, the 2 goes to the numerator, and we get minus of 3 by 2 into 2, that is equal to minus 3. And this is the value of the fourth question. So this is where I am done with discussing whatever I wanted to discuss in this video. I hope that whatever I have discussed in this video has been somewhere helpful to you in your preparations. Thank you for watching. Do check out other videos in this playlist.